The quadratic formula can be used to find rational roots and irrational roots, but it also can be used to find complex or imaginary roots. And once again, we've got our quadratic formula here, and we've got a quadratic equation, 3x squared plus 5x plus 4 equals 0. And we are going to use the quadratic formula to find the roots. So let's see, negative b, well that would be negative 5 plus or minus the square root of b squared, which is 5 squared, minus 4 times a, which is 3, times c, which is 4, square root of that, over 2a, 2 times 3. Well, we still got our negative 5 sitting out here, plus or minus. 5 squared is 25. And then negative 4 times 3 is negative 12. And negative 12 times 4 is negative 48. And you might notice something weird going on. And then 2 times 3 is 6. All right, so then we got negative 5 plus or minus the square root of 25 minus 48 is negative 23. All that's still over 6. Now, this square root of negative 23 can be written as square root of negative 1 times the square root of 23 over 6. And what is the square root of negative 1? In imaginary world, it is I. And so we have a complex root for this equation, quadratic equation, 3x squared plus 5x plus 4, and it is negative 5 plus or minus I times the square root of 23 over 6. You want to do one more? Does it really matter if you want to do one more? No, it doesn't. We're going to do it anyway. All right, so here we got x squared minus 4x equals negative 13. Quadratic formula sitting right here. You'll notice a graph over here. I'll touch on it in a minute. But in order to get this, I need to rewrite this as x squared minus 4x plus 13 equals 0. Now I've got this in the form of ax squared plus bx plus c. Now, I graphed this x squared minus 4x plus 13 that you see over here on the right, and you notice that it does not cross the x-axis. And we would say that there's no real solution to that, and that would be true, but there is a complex. We do have complex roots. And let's discover what those are by using, again, the quadratic formula. So now we got negative b, but b's negative 4, plus or minus the square root of negative 4 squared minus 4 times a, which is 1, times 13, which is, well, we'll figure that in a moment. And that's over 2 times 1. All right, let's start solving this. Negative, negative 4, then there's positive 4, plus or minus square root of negative 4 squared is 16. Minus 4 times 1 is negative 4 times negative 13. I believe that's going to be negative 52. Square root of that over 2. Okay, and then we got 4 plus or minus the square root of, let's see, 16 minus 52 is negative 36 over 2. And then we got 4 plus or minus, let's call it the square root of 1 times the square root of 36 over 2. And 4 plus or minus, well, the square root of 36 is 6. Square root, that's a negative 1. Square root of negative 1 is I over 2. And we can simplify that a little bit because 4 divided by 2 is 2. And 6 divided by 2 is 3. And so our complex root here is 2 plus or minus 3i. Let me say that one more time. Our complex root is 2 plus or minus 3i.